Alrighty, happy Tuesday, folks. All right, so we got a couple things today. Let me pull up our course repo here. There it goes. So project 2 was due as of 4 minutes ago. The lab from last week we're going to look at. We'll look at the project. We'll look at file input and output, working with files, which is awesome because now we're finally going to be able to keep data around between running our program. So we can run it and stop it and still have data for next time we want to run it, which is a lot of fun. We only really get through 11.1 through 11.3. Some of the advanced stuff we don't get into. You'll get into that next class if you do continue on in object-oriented programming with Java. If you want to take it this summer, Dr. Baugh is teaching it. I think he usually does here. Let me, hang on, IOCC. Here we go. Let me see how many seats we got left. You'll be lonely. Yeah, the door probably won't be unlocked. Wait, we want summer. We want CIS. You can take it. It'll be like the quizzes. Just anytime you want to take it throughout the week, go for it. You can open it, start it, come back to it later. Yeah, so the midterms, it'll be a D2L quiz, just like the quizzes are, but it counts for more points because it's the midterm exam. But functionally, it's the same thing there. I'll go over the format for it and show you last semester's midterm, so you can get a feel for what the questions look like. Let's see, 2151. Oh, it's waitlisted already. Holy crap. Wow. That one filled fast. So there are no seats left for that one. But when the payment date comes due and you haven't paid, they kick you out of the class and let people in on the wait list. So I would recommend, if you do want to take the class, to join the wait list so you can get access to it. Generally, not everyone pays, and they keep kicking people out. And then, like, every week you have to pay, and I don't know. It's a whole thing. I don't really understand the system. I apologize. It's not my. I don't have to worry about it usually. Sounds a little sad, but it's true. You are the school. You're the school. You're here now. It's good. So that one's there. A couple other fun classes. Wow, you got 15 people taking Python. That's crazy. Data structures. I'm teaching data structures this summer. So generally, we recommend people take object-oriented programming in Java first, and then come take data structures third, like a 1, 2, 3. You don't have to, but some of the stuff we do in data structures will make more sense if you've taken object-oriented programming in Java. You don't need it, but I would definitely recommend you do this one first, for what it's worth. I'm sorry? This summer, yeah, they're all online. Yep. I think they're all online as well. I got to look at my fall schedule. That one's coming out soon. This summer? I'm sorry. Yeah, so do check out summer registration, and then don't forget the Summer Momentum Scholarship, free money if you apply for it. I don't know how they determine who gets it. That's, again, not my area of expertise. But they asked us to remind everyone to apply for summer money. Yeah, and that's it. Come summer. Hey, Ancient Bags, thanks for joining on Twitch. All right, so let's do the lab first, and then we'll do project 2, and then we'll talk about file IO, and then we'll talk about project 3, and then we'll do the midterm review. We got a couple things tonight, but they'll go pretty quick. We don't do a ton with files, but it takes a little bit of time to get into how we work with them. So we'll work through that, okay? All right, so let me fire up IntelliJ here, and we'll work on the lab first. So for the lab, let me actually go and make a copy here, because we're going to use the tic-tac-toe game that we did using array lists and turn it into arrays. But I want to leave both copies out there for you. So I'll just make like a copy here. So we go open this. Come on, open. So the lab use it for arrays. Use what we did in class, the tic-tac-toe game. Then we're going to do a new lab later today on files. Does not have anything to do with this. Yeah, sorry. I'm probably saying the wrong things here. Open it. There we go. Explorer. All right, so here's week 9. I'm just going to copy paste this, and this is going to be lab. What's the lab number here? Lab 7. There we go. Thank you. Lab 7. Lab 7. All right, and then in IntelliJ, we'll just go open that up. So let's go Come on. Documents and GitHub 1500 lab 7. Excuse me. All right. All right, so here's tic-tac-toe with the array lists here, and we want to convert this to an array, the basic array. So first thing we got to change here is our private attribute. So this is just a character array of arrays, right? A two-dimensional array. That one's done. And then the board now becomes a new character array. What size? Size 3, but 3 rows and 3 columns each. What's cool with arrays is you get default values. Remember, array lists will start empty, so we have to go through and add all these new things. With an array, it already exists. We have to go set the value. So we're going to loop through row index, we're going to loop through column index. We don't have to add empty rows. All we need to do is take my board at the row index, at the column index, and assign it the empty square, right? That's our empty square, empty space, empty character, right? So now we've put an empty instead of the default character in there. I think the default character is like 0 or something, which is like a nonsense character. So going and changing the value, right? It is automatically sized. We'll just go and change it in here. Then when we go to string, right? Instead of an array list here, it's a character array. Char, not chart. Character array of row. For each row in the board, we want to do something. Now, remember, arrays themselves don't print out nicely when you put them in a string. But we looked at in the chapter, there's this arrays class that would do some cool stuff. So we can say arrays.toString, and we can give it the array here, which is known as the row. So we can take arrays toString of the row to get a string version of this array, add our new line character, and keep on going for every row on the board. We'll go and do all these things, we get our result back. So that one's done. The someone won by row. So the row here is not an array list, it's a character array for each row, and we don't use get here, right? We just use the square brace notation. So row at 0, at index 0 is not empty, and row at index 0 is equal to row at index 1, and row index 0 is, there we go, is equal to row at index 2. Oh my goodness, come on. There. It's trying to be helpful and putting in too many characters for me. Right, so we use this index notation rather than the get method, because it's just a basic array. There are no methods that we can use on it. It's all index notation. Right, someone wins by column. Now this one's a little bit different here because we're looping through by column, checking each row at a time. Right, so we're always going to use the column index, but the row is going to be either row 0, row 0, row 1, row 0, row 2. So these get square braces, right? So really, we could just do a find and replace if you wanted to save yourself a little bit of time. So, nope, that's not it. Oh goodness, that was the wrong button. Not that one. So is it edit, replace? Come on, where's replace? Find, replace. Okay, why do they hide it in the find menu? But sure. So we could replace this with index 0, right? I want to replace this. So I'll replace .get 0 with square brace 0. Get 0 with index 0. And really, every time I do it, I can just replace it, which is nice. Okay, now that one's gone. Now I'm going to do the same thing with get 1. So if I want to replace get 1 with square brace index 1, we'll replace those. Replace. This is the easy method, right? Replace get 2 with square brace 2, index 2. Replace. Now we're not done yet though, because so we still have some gets here. There's someone won by column. We were getting column index here. So again, we can just replace. I can say, hey, let's take this thing and find and replace. Replace column index with square brace column index. Right, so now we'll get the column index replaced here. There should be one more, right? Missing one more? Okay. Someone won by, did I spell that wrong? Oops, I have too many, forgot the dots here. Let's get rid of the dots. Dot. Get column index, replace. There we go. And get rid of the dots. Okay, we got that one. Now the is tied, right? We need to say this is a character array called row. And then for every character in that row, if it's empty, return false. Sure, that works. That one's quick. The get row index is just square base row index, square base row index, square base column index, and then again square base row index. Now there is no set method here. And so when you set a value, you still use the index notation. So it's row index column of column index equals the current player. We're going to assign it the value of current player. Let's change the, oh yeah, this line here we had commented out. Oops, that was there already. Right, so the board at this row, at this column, assign it the value of current player. I think that was all of them then, right? All right, now let's make sure it runs. Give it a run. See if we can play tic-tac-toe. All right, if you guys beat me, you can go home, and you don't have to take the midterm. All right, where are you going to go? X's, I'll be O's.
0, 0, 1.
0, 1. All right, I think I have to go in the middle here. So 1, 1. Where are you going next?
I want to take 1, 1.
1, 1 is, I'm there. You can't be 1, 1. 0, 0? All right, so I have to go to row 2, column 2 to block you. You got to come here to block me, right?
Yeah.
I mean, you don't have to. I can win if you want. Now that's row 2, right? Row 2, column 0. All right, so I have to go here to block you. So I'm going to go row 1, column 0. You got to go here to block me.
Yeah.
Row 1, column 2. All right, and I'm going to go here because I like symmetry. So I'll go 2, 2. We played this exact same game last time, and you guys got 2, 1. Game over. We did this last time. I'm sorry?
Let's try another one and let's go us in the middle.
All right, you can start in the middle if you want. Sure. Here, let me take out the rest of this garbage here real quick because we had a bunch of extra stuff here. If you guys win, it's not going to happen, but you can dream. You can't lose at tic-tac-toe. It's like if you know what you're doing, you can't lose. All right, 1, 1. All right, so I got to pick one of the diagonals, right, to block you there. Is that right? All right, let me just. Yeah, I got to go to a diagonal. All right, so I'm going to go 0, 0. All right, where are you guys going to go? No, 1, 1's the center.
2, 2.
All right, I got 2 votes. I got a 1, 2, and I got a 2, 2. This one's 1, 2. This one's 2, 2.
2, 2.
Other people have to vote here. We're tied. We're tied. You're not winning anyway. It doesn't matter. You can't.
Fine. What about 0, 2?
0, 2? You want to go here? I got 3 different votes. They all have 3.
0, 2.
All right, 0, 2. Okay, 0, 2. All right, I have to go here to block you, so I'm going to go to row 2, column 0. You got to go here to block me. So you're going 1, 0, right? 1, 0. All right, well, I got to go here to block you, so I'm going 1, 2. All right, you're going to go what, here or here? I know, it's tricky, right? All right, so what's that? Yeah, so no, this is 2, 1, right? Row 2, column 1. 2, 1. All right, so I have to go here to block you, so I'm at 0, 1. And you got to go here at the end. Oh, we don't have any symmetry now. 2, 2. Tie game. You know, sometimes it's no fun. It's when they're not even. It's all right. It's like my kids. I don't lose to them at tic-tac-toe either. My wife says that's mean. Is that wrong to not let your kids win in the game? I don't, when we play Dungeons and Dragons, I don't kill their. Well, I did kill my son's character, but he asked me to. He wanted to play a different character, so like, okay. So his character died. It was actually really funny. He fell off the top of a lighthouse. It was a good story.
Wow, that's brutal.
They went up top to the top of the lighthouse and stared at the glowing thing and got blinded. And then the druid cast, was it create water? Or no, water something or other. Water wall. So like it flooded the whole top, and he failed his deck save and fell off. It was entertaining. All right. Anyway, we're okay with the lab? Does this make sense? So just converting between arrays and array lists here. We want to get familiar with them, with arrays and array lists. A lot of people like arrays, and they're basic and quick. I like array lists because they're flexible, and you can add to them, you can take away from them. You don't have to tell them what size they're when they start. But if you only need 3x3, just make it a 3x3. It works out pretty well. That should go pretty well for you. So let me go commit that to GitHub here. If I can get the key, there we go. Come on, Windows key 1500 for winter. This is lab 7. All right, cool. And then let's do the project. So let's start up a new project here. This is project 2. Right, Java sample code. Don't check the Git repository box. Right, one more warning here. That one messes people up. And then one other thing, when you go to your repository, oh, it's not going to show me here. Hang on, let me pick my other one here, like the summer one or something. Don't click this button either. This one messes stuff up too, because the repository is not a project. You put a project inside of the repository. You don't have to, but that's the way we've done it, and we're using the GitHub Classroom workflow, so it gives you a folder, which is not a project. You put a project inside of it. So a lot of people have trouble opening their stuff. It's because you click this button, which seems like a nice shortcut, but maybe we're doing things a little bit funny here with that GitHub workflow. It makes life a little bit easier. I could give you a default starter project, but then like you get that exact same version every single time, and I have to change it every time there's new versions, and that makes me sad. I'd just rather give you an empty folder. So anyway, that's that. So we're going to make our electric vehicle, right? So we don't actually care what's in main here, right? Nothing has to live in main. We didn't ask for anything in here. We're not doing anything with user input. We're not asking the user to enter any values here. We're going to write the class and write the tests to make sure the class does what the class is supposed to do, assuming that maybe someone else will go and use this class somewhere. Maybe we could later, maybe someone else could later, that sort of thing, whatever we want to do. We're just building out the class. I'm going to go to my source folder here on a new Java class. This is my electric vehicle. All right, and then electric vehicle had a bunch of attributes, right? Let me go grab that here, make sure I've got the right list. All right, attributes for kilowatt hours in battery, max kilowatt hours in battery, kilometers per kilowatt hour, make, model, and color. Sure. So let's grab all these. So kilowatt hours in battery, this is probably a double, right? Because you can use fractional portions of this. It doesn't have to be a whole number. So if you had an int, you're probably going to have trouble here. So that's probably a double. You can comma separate these things and say they're all doubles. I think that's really ugly and I hate it, so I don't do that. So I'm just going to, for each of these, say that's a double, and that's a double. And then make, model, and color sound like strings, right? Here's a Ford, here's a Chevy, here's a Bolt, here's a brown car, that sort of thing. Sure. Oh, kilowatt has 2 T's? It does, doesn't it? Kilowatt has 2 T's. I can never spell that one right. And I'll pull those back in. So if you grab a couple lines and tab or shift tab, you can pull them in or out. Or you can just format the file too, but usually that goes pretty well. And then we want all of these to be private. Right? That's our good practice when we're writing classes, right? All of our attributes should be private. And we want to give people public methods to access these things here. Right? All right, so we have these. We want get methods for all the attributes. Now, you're welcome to write your own. I don't recommend it because that's a waste of your time. So right-click and say you want to generate getters. And we want to generate getters for everything. So I'll click on all of them. And then we get all of our get methods. Right? So get kilowatt hours in battery will return the kilowatt hours in battery value. Get's a pretty straightforward. A set method for color, only color, because it's really the only thing that we can change directly. You can take a car and you can paint it, and all of a sudden it's a new color. Right? Once it's a Chevy Bolt, it's probably always going to be a Chevy Bolt. Right? You're not going to change the manufacturer. You're not going to change the make of the car. Now you can do custom stuff too, and you can do stupid things with the body and make it look different. But really, it's still that original thing. So we're going to say you can't change those things. So if I don't give you a set method, you can't change them. Right? That's how the class works. It protects its integrity, saying, okay, you can't change this value. You don't have a public method here. So for set, all we need is color. So we're going to generate a set color. Just color, so you can go paint your car whatever color you want. Okay, so we got color. Now, the next piece here is not listed here. I apologize. It's in the rubric here, was the constructor. I don't know why this made it over in the rubric side, but hopefully that's not a surprise, right? Because you all looked at the rubric when you scored yourself. And you realized if you don't have a set method for these things, there's no way to give it a value aside from the constructor, right? If you default it to something, there's no way to change it, which is probably not good because not every car is a Chevy Bolt, right? A couple of companies make electric cars nowadays, several of them now, right? Even including a couple of startups, which is really neat because like the cost barrier of entry into the auto industry is really, really, really high. So it's kind of cool to see startups getting into that industry here to put some competition on the old companies because competition is good for people, right? It's supposed to be. That's the goal. So the Lucid Air, is that the one I heard made the news? Supposed to be really nice. We'll see. We'll see if they can scale. Tesla had the same problem. They built some like really expensive cars that did well, but they only made a couple of them at a time. Like to scale your manufacturing process is really hard to do. Turns out, like building physical things is hard. Building software is pretty easy because it's you just type some stuff and like you got some buttons you can click to distribute your software around the world. It's really cool. A sad story because I know you all care about my ridiculous stories. I'm trying to get a new Chevy Bolt. I used to have one and I sold it during the pandemic because we weren't driving anywhere. We just have one vehicle now because it was silly to pay insurance for two vehicles. And I'm trying to buy it. I got everything ready to go, and like the day of, like, oh, GM recalled something. There's a software patch it needs. That was 3 weeks ago, and they still don't have the software patch. So the software that I love is keeping me from getting a car. I'm a little sad about that, but it's okay. It's all right. We'll figure out this fancy computer on wheels thing one of these days, and they can patch it, and then I can go buy it, and then I'll be happy again. So, all right. Anyway, so the constructor here could accept values for the attributes, but default current kilowatt hours to 0. So we're saying all new vehicles come with an empty battery, right? So don't take a value for your current kilowatt hours because it's just going to be 0. You get a brand new battery and there's no charge in it. You got to go plug the thing in. Sure. Which also, oddly enough, in the news, there's a startup company that sells a battery to people to charge electric vehicles. Which sounds a little stupid at first, but you can charge this battery off hours when rates are lower, and then you can get more electric charge out of it than you can normally get off the grid, so you don't have to upgrade all of your electrical system. It's like the dealership's trying to put in 5, 6, 7, 8, 10 of these fast chargers. That's a lot of load on the electric system that they're probably not wired up for. I don't think that people have really thought through what it's going to mean to replace all the cars on the road with electric vehicles. That's a lot of electricity to charge these things when basically we've got like millions of generators running on the roads right now. To replace all that with batteries with no generators. It'll be fun. It'll be fun. So we'll see how that happens. But anyway, we're going to default to 0, and we can charge it up later ourselves. So let's go generate a constructor. What attributes do we want? Well, we want everything except kilowatt hours and battery, right? So you tell me the max, you tell me how many kilometers per kilowatt hour, you tell me the make, you tell me the model, you tell me the color. Great. We'll go take all those values and we'll go set them. Then I'm going to say my kilowatt hours and battery equals 0, right? Assign it 0. It starts at 0. So every new vehicle has no charge in the battery. Sorry, I can pop that up a little bit here. Okay, so that's our constructor. Again, you can write these by hand if you want. I just don't like to do more work than I need to, right? And if you want to change the order of these things, you can change the order of these things. It doesn't matter what order they're in. You just, whatever the order is, we have to follow that order, right? So the first thing will be the max, the next thing will be the kilometers per kilowatt hour, and then the make, the model, and the color. Sure. Okay, so we've got those. Now we're going to have a drive method that accepts an argument for kilometers to drive. How far do you want to drive this electric vehicle? We're going to see, do you have enough charge in the battery? And if you do, take that charge out of the battery and tell you yes, return a true. If you don't, we'll just tell you false, you can't do that. Don't try, right? Don't try and go 1,000 kilometers if you can't get that far in your charge, right? Plan to go to a charging station and hope that that thing's functional and operational and not in use while you want to charge, because that is also fun. All sorts of fun infrastructure problems that we have to solve in the future here. But yeah. So you're asking if we have no power, how do we charge our cars? Because it takes a while. Yeah. So different charging, they've got different levels of charging systems. So if you just plug into like a regular home outlet, you can charge about like 4 miles worth of charge per hour or so. And it sort of depends. If you plug into a 220 outlet, or what they know when I was like the level 2 fast charger, you can charge about 25 miles worth of charge per hour. So if your battery is like a 250 mile range battery, you can charge in about 10 hours to full charge. Again, it's all sorts of factors will influence this and your battery life and things like that. But then they have the DC fast charging, which charges about 100 miles worth of charge or 200 miles worth of charge in an hour or something like that. That's really fast, but it takes some interesting hardware, and you're probably not going to install that sort of thing at home. But that's the thing, they can build those or put those out at other places for faster charging. Yeah. Yeah, so we've had electric vehicles been around for a while, but it's not practical with the current infrastructure. There's a lot of work that has to happen to get the infrastructure up to where it needs to be, so we actually can have the majority of electric vehicles on the road, and we'll see what happens there. It'll be interesting. Anyway, we're going to write drive, though. So our drive function, drive method here, so public boolean is going to return a true or false, whether or not it's successful or not. Drive, and it's going to take a, could be an integer if you want a whole number of kilometers. If you want it to be a double, double's fine too. I think double makes sense because we're going to do some arithmetic with division, and you want to make sure we've got doubles anyway. This will be our kilometers to drive here. So to take the kilometers to drive and turn it into the number of kilowatt hours required, we have to divide by the kilometers per kilowatt hour. Right? If I want to drive 10 kilometers and I get 5 kilometers per kilowatt hour, 10 divided by 5 means I need 2 kilowatt hours worth of charge to drive this far. So I'll have a double for kilowatt hours required for distance is going to be my kilometers to drive divided by my kilometers per kilowatt hour. Right? Now I can see if this number is less than or equal to what's in the battery. Do I have enough charge in the battery? So if my kilometers per kilowatt hour, kilowatt hours required for the distance, if that is greater than the kilowatt hours in the battery, I'm going to return false. Again, either way, you could do the true option first and then return a false, or you could check first and return false and then do the next arithmetic. It's just a style preference. Either one's okay. So if you need more kilowatt hours than you have in the battery, tell you no. You can't drive that far. No good. If you can, then great. I'm going to take the battery, what's in the battery, and subtract how far we're going to go, how many kilowatt hours that needs to go that distance. Right? Now we've taken out that amount of charge and we can return true. Yes, you were successful. You're able to drive that far. We took that many kilowatt hours out of your battery charge. Great. That's drive. And then charge is another public boolean that takes a double for kilowatt hours to charge. Now with this one, with charge, we want to make sure that, you aren't overcharging your battery. Right? So if I want to charge 100 kilowatt hours, my battery only is a 50 kilowatt hour battery, I'm going to tell you no, don't do it. Bad stuff will happen. Now, in the real world, the charging system itself is smart, but we're going to pretend this is stupid, and you have to tell it the number ahead of time. Because again, it's just some examples here in code. We're not actually going to use this code in real life, so that's okay. So same idea here. So I can check first, hey, if my kilowatt hours in the battery plus my kilowatt hours to charge is greater than my max kilowatt hours in the battery, return false. You can't do that. Too much. You'll explode the battery. Bad stuff happens when you explode batteries, right? I think they catch on fire. Batteries are gross. Like, it's interesting technology. I'm glad people are studying them and trying to figure out how to make these things work better, but don't mess with them. Right? I think that's the moral of the story. So if you do have enough room, right? And again, notice I don't have else's here because as soon as you hit a return, your function stops. So an else here would be redundant. An else here would be redundant. It's okay. You're welcome to have it. It's not going to hurt anything, but you've done more work than you need to. And again, we frown on that sort of thing because we're lazy. So we'll take our kilowatt hours in the battery and we'll add the kilowatt hours to charge. There's no conversion here, right? This one we have to take kilometers and convert to kilowatts. For charging, you just take the kilowatts and just add it to the battery. Great. Let's go add that many kilowatts here. And then we can return true. Okay. We're halfway done. Now we're going to include unit tests for 100% code coverage. I misspelled that here. Forgive me. Code coverage for charge and drive. Again, the set color, it's a good thing to do, but if you can do these ones, I'm sure you can test set color. right? You set the color and you check, do we get the color back out? It's not all that useful, but these ones are interesting, and we have to deal with this idea of 100% code coverage, which means, did this line of code run when my test ran, and did these line of codes run when my test ran? Because they're mutually exclusive, right? One and only one of these will run each time I call charge. So I need to test charge twice, right? Once where I expect to get a false, once where I expect to get a true. Same with drive. Once when I expect to get a false, once when I expect to get a true. I'm going to have two different tests here. Bless you. So to get to tests, right, we're going to right click on our vehicle and say go to test. It says, hey, I didn't find any, so let's make some new ones. Great. And create it in the same source, go for it. So we want drive and charge. Don't worry about the other ones. We'll say okay. Now we get the red lines, that's okay. We just wait a second here, get the red light bulb. We want to add JUnit 5 to your class path. 4 works, but it's a little slightly different than 5 for lots of reasons, so that's fine. We'll say okay, and it should light up. Right, we got it added. Now we're going to do this AAA format, right? We're going to arrange, we're going to act, and we're going to assert. Right? Set up all the variables you need, call the code you're testing, get the values back out, and then assert. Does it match what you expected? Right? So for drive, this will be drive. Let's do successful first. Successful first. Actually, let's do charge, because you can't drive a car with no charge. So we have to charge it first. So let's make sure charge works first, because right, drive kind of depends on charge, because you can't set the kilowatt hours in the battery in the constructor. So we have to use charge. So let's be successful for charge. We'll arrange, we'll act, and we'll assert. So I'm going to have the expected kilowatt hours. So a double for expected kilowatt hours in battery. Let's just say it's 10, right? Sure. So here's 10. And then I need a vehicle to test. So let's make a vehicle or electric vehicle. Vehicle equals a new electric vehicle. We have to give it a couple things. So you have to give it the max kilowatt hours. You have to give it the kilometers per kilowatt hour. We don't actually care what it is here, because this is just our charge method. We're not actually going to drive it anywhere. We give it a make, a model, and a color. We don't care what those values are, so I'm just going to give them empty strings. Right? Doesn't really matter what the make, model, and color. Those aren't important to the test. Okay. Now act. Now we're going to try the charge method. So we're going to get a Boolean for the result that'll equal my vehicle.charge, and I want to charge it my expected kilowatt hours. So it starts at 0. I charge at 10. It should charge to 10. Right? 10 is max, so fine. It should charge up to max. That's fine. And then we'll get a double for the actual kilowatt hours in battery is going to equal my vehicle.get kilowatt hours in battery. Right? Get the value that the vehicle thinks it is now. Let's go see what that result is. And we can assert these are true. So we're going to assert true for our result. It should have given me back a true. This should have worked. And then we're going to assert equals the expected kilowatt hours in the battery and the actual kilowatt hours in battery. Now, if you made these doubles, you're probably going to run into this. Let's see if this gives us this error here. Oh no, it passed. Okay, interesting. Usually the double gives us more trouble here. Do we not need that? Okay. Assert. Okay, sure. We'll leave it. Sometimes with doubles, because Java's bad at arithmetic, you can give it like these are close enough, but I guess it's working here. That's fine. Cool. So charge was successful. We can do this again now, where charge is unsuccessful. So I'm going to copy paste here. So we'll say charge unsuccessful here. So if the max is 10 and I charge it, say 20, it should give me back a false, and the kilowatt hours in the battery should be 0. It should not have changed. Right? If you can't charge it that much, we just said no and didn't do anything. So we should assert false and the actual and the expected match. Let's give this one a shot. So unsuccessful works. It's a little funny of a word here, but unsuccessful, maybe returns false might be better, but that's I think we know what that means. All right, I'm going to change it now. This is returns false. All right, and then successful will say returns true. Sure. All right, now drive. We can come back to drive. So arrange, let's just copy paste all this here. We have an expected kilowatt hours in the battery. So after I drive a certain amount, what do I expect to be left here? So I'm going to go charge it up to 10 here. So let's go charge it up to 10. And then if we get 10 kilometers per kilowatt hour, if I drive 10 kilometers, right, 10 divided by 10 should be 1 kilowatt hour. So I should expect to have 9 left after I drive. So we don't need the result here either. We can get rid of that. So our result is my vehicle drive will drive 10. So I charge at 10, then I drive 10 kilometers. 10 kilometers divided by 10 kilometers per kilowatt hour means it should use 1 kilowatt hour. 10 minus 1 is 9. I should have 9 left in the battery, and this should have been successful. I was able to drive that far. Let's try this one. All right, that one passed. This should be returns true. All right, and then we'll do one more here where it's false. So if I forget the charge line here, and I don't charge my vehicle, turns false, then should have no charge, right? Try and drive 10, should give me back a false, and I should still have 0 left in the battery. All right, let's give that, I can run them all here. Let's run them all. All right, they all passed. So in terms of code coverage, right, in my class, I know that at some point I'm returning a false, and at some point I'm returning a true. So I have 100% code coverage of the drive method. Now, just because I've tested it doesn't mean I'm not going to have any bugs. I'm much less likely to have bugs because I've tested it, right? Rather than I just wrote something and hoped it worked. We actually tried it and figured it out, and it did what we expected it to do. It's possible we have other things we didn't catch, or we just expected it to do the wrong thing. If we did the arithmetic wrong, and I expected it to do the wrong arithmetic, it will test perfectly fine because it does the wrong arithmetic. So if I don't understand the problem I'm solving well enough, it's going to test perfectly fine because I did it wrong, and I think I'm doing it right, but I actually did the wrong thing. So just because we have tests doesn't mean we're bug free, but we're much less likely to have bugs because it's doing what we expect it to do. So again, there's no perfect way of making sure your code's bug free. Mistakes can happen in all sorts of different places here, but we should have a much better feel that what we did is right. Okay, so go ahead and commit that one here. So this is project 2. And let's take a look at the rubric here. If we're going to do a self-assessment for ourselves here. Do we have a constructor that accepts values for the attributes and defaults current kilowatt hours to 0? Yes. Now this is worded a little funny here. So if you took an argument for current kilowatt hours, but you still set it to 0, good. I'm okay with that. Now you shouldn't have asked for one because you're going to ignore it. And why ask for someone to give you something if you're going to ignore it? That wastes everyone's time. But you're not going to lose any points for that, right? Because it is worded a little funny here. The drive method. If it works, 4 points. If it sort of works, 3 points, 2 points, 1. What is the range of sort of works here? Great, partial points are fine. Charge, and then test for drive, and test for charge. Right? 2 points for the fail test, 2 points for the successful test. Pretty much. I think that works out, right, for each one of these to make sure we have 100% code coverage. That's unreasonable? All right, awesome. So you notice this one was worth more points than the last one here, right? So we had 10 points, 15 points, 20 points. We'll do a couple more points for project 3 because you don't get to forget anything. Things just keep building on themselves as we go, right? Just like math class. If you ever get to calculus, some people say it's a mean trick to make sure you learned your arithmetic. All sorts of arithmetic and algebra in calculus. So that sort of thing. All right, so we got to talk about file I/O. We got to talk about project 3. We got to do midterm review. I've been going only about 40 minutes. Do you want to power through, or do you want to take a break now before we start new stuff and break in the middle? Totally up to you folks. Keep going. All right, I'll keep going. So let's talk about file input output. That sound good? All right, so let me pull up Java notes here. So this is chapter 11. We're jumping around a little bit here, and again, we don't get into the networking side of things. So just the first 3 sections of this chapter. Sorry, I can't make that any higher right now. It zooms a little funny. So section 1, section 2, section 3. And we're not going to even do all of the stuff with files because there's types of files we're going to get to. And we're not going to use text IO either because we don't need it. All right. So 2 types of files. There are character streams and there are byte streams. We're not going to deal with the byte streams. The big difference here is byte streams or binary files have a specific format in which they're read based on a particular program. So if I want to open up something like Microsoft Word here and say, let's start a file here. So here is some text. And I'll just go save this, save it on my desktop. why the OneDrive? No, come on, really? Browse to the desktop. Put it here. Is that still in the OneDrive? Okay, sure. Why not? All right, so we've saved some text here. It's not a text-based file, so when I go and open it here, it's going to open with Microsoft Word. It's a binary file that Microsoft Word knows how to open. So if I want to open it with a particular program like Notepad that knows how to open text files, you get garbage. Now, some things come out as characters, because there is some character data here, but most of it is just gibberish. This is all the data that's in the Microsoft Word file here, just to save, here's some text. It's a lot of stuff that goes into it, right? But this is a binary file. So us reading this and trying to do something with it, the chances of us being successful are pretty low, because we have no idea what the Microsoft Word format is. That's okay. So we're not going to deal with binary files. Now, text-based files, things like if I make a new text file, right? New text document, sure, test, right? We can open it up and we see text because it was text. So this is stored as characters. So each individual character is stored and saved. When we open it up, we see just the characters. So all of our Java program files have been text-based files, right? When we open up GitHub, we see all these things in text here, right? We can see, hey, there's an XML file. This is text. Here's another XML file. Here's an IML file. These are all text-based files here. All the Java files are text-based files. You can see the text content. They're not binary files. In our folder here, let me go open this one up here. So let's open up project 2. Remember, one of the things that happens in this output folder is Java gives you these class files. Remember, class files are the Java bytecode, things that the Java virtual machine knows how to run. So when you want to run a Java program, it reads these files. It doesn't read Java files. You compile Java files to class files, and if we want to open up one of these things with Notepad, guess what kind of file it is? Is it going to be a binary file or a text-based file? You can take a guess. It's okay. Binary. That's a good guess. We get garbage. I mean, some things actually show up here, like Java lang string, Java lang string, Java lang string, code, line number table, local variable table, this electric vehicle, kilometers. So some of these things we see text of. There is text data, but the format of the file itself is a binary file. There's a bunch of nonsense here that we don't need to know what it is, because the Java virtual machine knows what this stuff is, and Java can read class files, right? So binary files need a particular kind of program to open them and read and write from them. Now, binary files are great. They're efficient for storing things, and programs can work with them really well. But the downside is you can't just open them up in Notepad and edit them, because they need a particular format. So you need a particular program to open them. So we're going to focus on using text-based files, because that makes our life easier. So we're just going to use our character-based streams. Now, there's a couple things that go into it here, and there's like a lot of sort of this thing uses this thing, which uses this thing we're going to get into. So we'll take a look at using print writer. So print writer is going to let us print and write to a file rather than print line out to the console. So you can make a new print writer given something here. So there's a whole, let's see, that's the reader, that's the writer. Oh my goodness, one of these things. That's the, where's my writer? Oh my goodness. Oh, yeah, one of these things, print writer. Oh, this is the next section. I should learn how to read here. So writing to a file, we're going to use a writer. Reading from a file, you use a reader. Works out pretty well. We'll get to writing and files in just a second in the next section here. When you want to read something, you can go and reading text is really easy because the scanner class does it for us. You don't have to use all these other readers that use readers thing. We can say, hey, scanner, will you go read this file for me? So the other way you can do it is you can use a buffered reader, which uses an input stream reader. It's kind of ugly to do it like that. Scanner's a lot easier. So if we use scanner, we say, hey, scanner, here's where I want you to read from. Go read from here. So instead of being system in, which reads from our standard input, we give it, what is the source of characters here? And we use all the same methods here. We usually next line, which is awesome. Now, when we're dealing with files, you might know how many lines are in it, or you might not. Depending on if we wrote the file ourselves, we know exactly what's in it. If we're just reading a file to see what kind of input's there, we don't know what's left. So you can ask Scanner, hey, is there something next for you to read with this has next? Say, okay, hey, if there's something else for you to read, let's keep on going. So we can put this in a loop as we read our files here. So, and this serialized stuff, don't worry about that. That's all the stuff you'll get into in the next Java class, dealing with binary type files. It's cool stuff, but it's all binary stuff. All right, so when we have files, right, dealing with specific files, so not just character streams, which you could use over the network or from a database or other interesting places here. This is specific to files on our computer here. We'll go make a file reader. So a file reader, you give it the name of the file. What file do you want it to read? Okay, and then when you're dealing with file input and output, bad stuff can happen that can crash our programs. Exceptions can happen. Like when we're dealing with arrays, if we give it the bad index, we get the array index out of bounds exception and our program crashes. Turns out files will also crash, but we need to do something about it. So Java won't let us just run the thing here. So you have to handle dealing with those exceptions. Did it pause? Oh no, there it goes. All right. So let's go and start up a new project. So this is, my goodness, what week are we in? Week 10? Week 10. 10 files. So if we want to write to a file, so we get rid of this hello world here for a minute. So we're going to need a file writer. File writer equals a new file writer. And we'll call it, I don't know, test.txt. Notice it added the import for me automatically. It was really nice and handy. If you need to, you can click the red line and do it. Now this red line, there was a different error. It says unhandled exception, java.io.io exception. It's possible that an input-output exception, that's what IO stands for, input-output exception could happen. Java does not let us continue without doing something about it here. So we'll fail to compile here. We haven't got to exceptions yet. We'll get to that after the midterm. Don't worry too much about it. So we're going to click the little light bulb here. I'm going to say surround with try catch. That's the easiest thing to do here. This throw new runtime is not great here. So we're just going to print the exception here. So if a bad thing happens, we'll just print it out, and that's okay. If an exception happens, your code stops immediately. So no more code will run inside this try block. Don't worry too much about it. We can get more to these later. I guess maybe the other option's better here. Hang on, let's see. We can do this. So that first option, add the error to the method signature, we can do that. We'll say add exception to method signature. So we're going to add in here to public static void main string args that it throws IO exception. This is us telling Java, hey, I know this thing might crash. I don't care. Let it crash. We'll get to how we handle it. We'll get to how we handle it after the midterm, after that, because that'll make life easier. You don't have to worry about the try catch blocks. Okay. So I have a file writer. Now that I have a file writer, I get some options. So I can write a given string. Sure. So what do I want to write? So let's write hello world. When you're done, you want to close it. So when you're working with files, you want to do three things. You open the file, and then you will read or write the file to the file from the file. And when you're done, you'll close the file. If you don't close the file, when your program ends, it'll close it itself. It's a good habit to get into because in longer running programs, if you leave it open, it's using resources. And then if someone else tries to go and use the file, it's going to be upset and sad about it. So sort of optional, but bad to not close. So the right thing to do is to close your file when you're done with it here. So I notice I added the .txt myself. These file extensions are just shortcuts for your operating system. Right? When your operating system sees a file with the .txt, it says, oh, it's a text file. I know what to do with it. I know how to open it. Right? You don't need to have file name extensions. They're completely optional. They're just a shortcut so that the computer knows what to do with that particular kind of file here. So I'm going to leave it in. It makes life easier for us. And let's give this a run. And now you'll see a new file showed up over here. So when you give it the name of a file, it is going to create the file in the directory in which the program is running. Doesn't mean a whole lot here, but the program is running in my, where's my folder here? This one here. C users, Eric C, documents, GitHub, week 10 files. That's where it's running from. So it gets created in that folder, week 10 files. So we can open up the file, we see, hello world. We wrote a file. Hooray. It's very exciting. Now we do FileWriter.write. Happy Tuesday. Tuesday. There we go. I love spell check. Spell check is the best thing in the world. Let's run this one. Uh-oh, missed a semicolon. Nope. Semicolon. There we go. Run it. All right, now it worked. So let's check out test.txt. We get hello world, happy Tuesday. There's no line breaks. Like system.out.print doesn't give you a line break. Print line does. Right? So we have to go and manually add our line breaks if we want. There's no write line. So it's just write. So it will write whatever we give it here. So if you want to add a new line character, you have to add it yourself. Like new line, then happy Tuesday. When we run this one here, and we open it up again, now we get the new line character, right? Happy Tuesday. Now notice it. Let me put something else in here. Like here's some important data, and I run my program. What's going to happen to my important data? Any guesses? Yeah, we lost our important data. So when you open a file for writing, you've basically erased it, and then you write the new contents to it. So you gotta be a little bit careful here. We'll erase what was in there. So if the file exists, it erases it and opens it up for writing, or really it just puts a new file on top. If it doesn't exist, it creates a new file, which is pretty handy, right? It's doing what we expect it to do here. So we can write files, right? With our, where's the writing here? No, that's reading. We wanted the writing. Print writer. Oh, I'm sorry, that's file writer. So if you want, you can use print writer to do some additional things. So print writer is a little bit nicer here than file writer. The silly thing about print writer, though, is that you have to give it a file writer. So like you make a print writer that takes a file writer, but print writer is a little bit nicer for us here. It's used to printing. So let's change this up here. So let's make this our print writer. Print writer, print writer equals a new print writer given a new file writer here. And now this one doesn't get imported automatically. I don't know why, but Alt-Enter will add the import for me. Now, if you don't like listing all these out by yourself here, one at a time, which is still not the worst thing in the world to do, you can add a star here. Java.io.star means add everything that's in the Java IO package, please. That's a shortcut. So a lot of people will add the stars. It's technically more efficient to skip that, but we don't really care one way or the other for our purposes. And usually I just let the code get written by itself. So I'll usually list them all at one at a time. But if you want to start with a java.io.star, you'll get the rest of them for you. And now with print writer, I'm going to say print writer. Oh, here, let me leave these commented out here. This is the file writer version. Let me do that. So this is file writer, the new file writer given test.txt. Oops. All right, so we'll leave that one commented out. So for file writing, so for print writing, you can say print writer dot. Now this one gives you print line. Remember we did system.out.print line? These ones are a lot more familiar here. So I can print line, and I can say hello world, and then I can print line, happy Tuesday. Do you think I need to do my own new line characters with print line? No, we don't have to do that because it's going to do it for us. It's printing a line for us. So it's a little bit nicer to use, even though it's a little bit more awkward to set up. Let me give us a little wrapper here. So hello world, happy Tuesday. And then again, you do the same thing and close it when you're done. So now if we take a look at test.txt, now notice there's a line 3 here. We didn't have a line 3 before because after printed happy Tuesday, it added the new line character. So the next thing we write is going to be on line 3 here, ready for us to go. Usually we don't care if there's an empty line at the end, but just be aware you'll get an empty line at the end if you use print writer. So this is a little bit nicer here. Now print writer then also can be smart here. So you can give it just the new file writer, or is it true? No. Is it print writer? Hang on, one second. File writer. This one? Ah, no. So the file writer. There we go. The file writer here. If you want to append to the file here, where did I put this? Like over here. Use the second argument of true to append. Is that a useful spot? Oh goodness, a useful spot to put that, like kind of tabbed in. I don't know, when using file writer. Let's say you have a second argument, right? We're gonna say you can give it the append mode. So with append mode, when I run it here, it's not going to erase my file. It's just going to add to it, right? It'll append to the file. So as many times as I run it here, then it's going to keep on going. Hello world, happy Tuesday, until we get bored of it. So if you want to keep your data, you can use append here in the file writer. Is that a question? Yep, you just double click on it when it's over in your project view on the left. Yeah, so we were creating a file named test.txt. Yep, and it will create it, and we should be able to see it here if it worked. So depending on what we're doing, append is good. It's not always useful. Like sometimes you want to replace what was in there. So usually I don't use append. Let me leave that one here as a second. Let's do that. One more. So I'll leave the other print writer version here. This is the append mode. Is that helpful? All right, we'll put it back. And then we get just the 2 lines here that we wanted. So that's writing to a file. So you give it the name of the file. Now, what if you don't want to put the file inside this week 10 folder? Right? What if you don't want it to go here? You can give it a path if you want. So this is known as a relative path. It's relative to where the program is running. If you want, now Windows gets a little funny here. I'm not super familiar with Mac OS, what it does, but generally you can't write things right to the C drive. It's a little bit protected. But if you make a folder like temp here, to put some temp files in, you can write to this folder. So just if you give it a full path, don't just use the C drive, like give it the whole path here. So I'm going to use C temp. So if I want, I can say, hey, C:\temp/test.txt. So I want to put the test file in the C temp folder. C drive, temp folder, test.txt. Let's give this a run. Do I have one in there already? I do. Let me erase those. Sorry. There we go. Let's give that a run. Now when I open this up, I see test.txt. It has, hello world, happy Tuesday. Life is good. We like that. Now, for what it's worth, Windows likes backslashes in the file paths. I don't know if you can see that, C:\temp. I gave it a / because I'm lazy. Remember, if you put a backslash in a string, what does Java do? It thinks it's an escape character. So really, you'd have to put 2 backslashes in to say, I really want a backslash here, right? And I really want a backslash here. Java can also figure out if you use /. It's decent at this nowadays. So Mac OS and Linux use /, Windows use backslashes, but Java can figure out the difference. You don't even have to like do any special conversion. You just use the / that are easy, and Java says fine. So that's a full path here. So this is a full path to a file. Now, do be careful you don't overwrite files here with this. The temp folder, probably pretty safe. Don't start overwriting files in the Windows directory or your program files directory. Bad stuff is likely to happen. And that's sort of why we have this file permission sort of stuff happening. You want it to not shoot yourself in the foot, changing files you shouldn't change. So that's the full path here. Again, I generally will stick to relative paths because that just makes life easier for me. So if I want, I can make a folder inside of this folder. So test/test.txt. Or how about this is how about we call it like logs? We make a logs folder, and we start putting stuff in a logs folder, right? So when I run this now, it's going to give me doesn't exist. There is no logs folder. So Java will make files, but it won't make folders. That's a little sad. So you can make a directory if you want. So what's that? Java make directory. Let's just go search this here. On Stack Overflow. New file, path, make ders. Sure, why not? So we'll say this is a file log directory equals a new file given logs. So file's not imported right now. Let's go add that. So this is a file java.io.file. There's a class here. So I can say log directory.makeDirs. MakeDirs? I think it had an S. So I don't remember the difference. So let's go look it up. So this is the Java file class. There we go. I don't know what I was thinking of. I don't want 7. 7's old. Let's go 8, 9, probably 8. I don't remember here. There's all sorts of different versions of the Java. This is Oracle Java documentation. I think we've gone here like once before. Does ring any bells? We've not gone here before. So if you want to look up what something in the Java library does, they've got a nice little location that has all the information about it here. So this is the file class itself that tells you the different constructors, tells you all the methods, what they do. Good stuff here. I'm going to search make dir. Okay. Creates the directory name of this abstract path name, or creates the directory name of this abstract path name, including any necessary but non-existent parent directories. Oh, so this will make all of the directories in the entire path. So I can have like log/3/14 if you want to log for Pi Day. Happy Pi Day, by the way. The best of days. Like my favorite nerd holiday. Mario Day was pretty good too, March 10th. But Pi Day is pretty good too, because you could eat pie. Don't eat Mario. So yeah, make dirs, then we'll make the logs folder. Should do it for us. Oh goodness. Really? Can we just make the folder? Can we give it just logs? Maybe it's just logs. Okay. Just logs. Yeah, okay, that's right. The forward slash, I think I probably just added the new folder here. Add a logs folder. Yeah, I made a logs folder here. So slash was the IC drive. Oops. Just the forward slash. Yeah, I don't need that logs folder. We can delete that one. All right. So makes the logs folder, and then we put a file inside of it. Now we have a test.txt inside of that. So these are still relative paths. Right, so we'll create the directory. Doesn't exist, and it exists. It should be fine to run as many times as we want here. It's not going to hurt anything to call make directories if they already exist. Okay, life is good. And this writes to the file in the log directory. Logs directory. You know, directory is the same thing as a folder. I'm sorry, I think I just use those interchangeably without explaining it. Directories are just folders. Folders are like repositories. Repositories are folders that get watches. Got all sorts of names for things because that's what we like to do in programming land. Everything has like 3 names and 3 ways to do it. Oh, someone wants a dad joke. You got it here. Oh, and it's 7:06. We should probably take a break in a second. So why don't I read a dad joke? Oh, I have one. Actually, I just read and I was really happy. And it's very fitting for daylight savings time. So I was thinking about how the rotation of the Earth and like the setting of the sun and the rising of the sun. And you know, I was just sitting and thinking about it, and I was up all night and trying to understand like why do we count hours and why do we have so many hours in the day? And then it dawned on me. Thank you. That was terrible. Or you know how like the rotation of the Earth really makes my day. No claps to that one, really? Okay. Extra points for clapping. Extra points for clapping. You have to humor me, right? All right, let me put some music on while we take a minute. We can back. It's still sunny out. This is crazy. Alrighty, welcome on back. Here we go. So first, I wanted to share. I love this. Posted in the memes channel. My socially acceptable chemical dependence. I love the smell of it all day long, not just in the morning. This is an all-day drink. Oh, it's gone now. So that was five espresso shots. All right, and this one's for all of you out there as well. You want to learn to use the debugger. It really is your friend. Printing's okay, but really just use the debugger. It's your friend here. All right, so we got that. So we wrote files. We haven't read files yet, right? So to read files, again, we're going to open it, we're going to read it, and then we're going to close it. So we're going to make use of Scanner. When I posted this Stack Overflow developer survey, they do this every year, which is really cool to see. Someone was asking about the Go language and some other technologies and sorts of things. So this is, you can see of people who are professionals, all respondents, people who are just learning, what they like to learn, that sort of stuff, which is cool. And see all the technologies, top paying technologies. It's a fun one too. Like what stuff do they learn? Web technologies, web frameworks, or frameworks and libraries, all sorts of fun stuff. What platforms? So interesting things here. Databases. There we go. So fun stuff out in the survey. I posted that in Discord as well. So we wrote files with print writer using a file writer because it makes our life easier. You don't need the print writer. You're welcome to just use file writer, but then you have to add your own new lines, which is usually sad, just because it's more work than you need to. So like do one extra bit of typing here so you don't have to do an extra new line every time. That's all. There's a little bit of a trade-off here. Let me close our print writer. So for reading files here, let's go back to our Java notes here. So we're going to use scanner here. So scanner will take a file object, is usually the way to do this. So you make a file with a name and you feed it to scanner instead of system.in. And then scanner can go do something with it here. So let's make a file here. This is my file, I don't know, file to read or something. It's a new file, and we're going to give it the name like test.txt. Or this is logs / test.txt. Okay. Then we're going to go try and read it here. So let's say scanner, this is my file reader equals a new scanner given, now not system in anymore, we're going to give it the file to read. And again, let's go add our imports, sure. Alt enter, come on, import the class. Here's a file to read. Now, if you don't have this IO exception thing here, this will also be a red line for you here. And it's going to say, hey, you can either add the exception to the method signature, which is fine for now, we haven't learned it the right way, or if the try catch is the right way, but again, we haven't done it yet, so why bother? So we'll just pass the buck and say, hey, Java, we're going to crash. It's okay if we crash. Not really, but for our purposes, it's okay. We haven't figured out how to not crash yet. So we'll just say, hey, let's crash. It's okay, Java. We'll give it the file to read. Then we're going to use that while has next. So I can say while my file reader dot has next. While there's something for me to read, let's go read it. Now in this case, it's all text. It's not very interesting. So I'm just going to say, hey, here's my string for the line is my file reader dot next line. Right? Just like we did before, but instead of getting keyboard input where I have to type something in and hit enter, it's going to read the line out of the file. And then read the next line, and read the next line, and read the next line. What do we want to do with it here? Well, for now, I'm just going to print it back out because there's not really anything interesting to do yet. We'll just print it. So I can go read my file. Java IO exception must be caught. I thought we did. Oh, that's not file, not found exception. Sorry. This was supposed to be an IO exception. There's a hierarchy to exceptions. We talked about classes and inheritance. There's inheritance when it comes to exception. So IO exception is the parent exception for all things IO, and then there's specific ones. So it's saying, hey, we weren't catching IO exception. We were only catching the specific file not found exception. Where did it go? Oh my goodness, cancel. File not found exception. So this is a child of IO exception. So if we catch the parent type IO exception, we'll catch all the types here, right? That cool polymorphism thing. You can treat something as its parent class, right? You remember that. Good, good. All right, let's give it a try. So we get hello world and happy Tuesday. Not very exciting because we just wrote that ourselves to the file, right? So let's just pretend for a second here. What do we want? Let's like not write the file real quick. Here, let's just get rid of this logs here. Let's just make a test.txt file. And let's go modify our test file here. So here's some data, more interesting stuff, yay. Okay, and now let's go read that file here and see what's in it. So here's some data, more interesting stuff. Yay. And still not very interesting, but let's put some numbers in here. Why don't you shout out some numbers?
1,
1, 5,
5,
5,
5,
5,
21, 2.
21, 2. I'm sorry?
Oh, sorry, I repeated one.
More fives?
Oh, no, the 21.
21. All right, gotcha.
Oh,
Pi 3.141592658. No? Shoot. 3.14159, right? Is it not 926?
I lied, I have no idea.
Come on, kill me. Million digits of pi. 3.141592653565265 Okay, I was close. So I had it to, let me zoom that in here. 1, 2, 3, 4, 5, 6, 7, 8 digits. You guys are impressed, right? How lame am I? I should not know that. I don't know why this is in my head. Someone made the news because they memorized pi to like a ridiculous number of digits and they're a kid and they wanted to get to 100,000. I really want to smack the kid, which is wrong. I should not say this, but like, kid, do something better with your life. There are better things to do with your life than memorize pi to 100,000 digits, right? Like, can we be honest? Okay, it's entertaining for you. Go for it. You have your own hobbies. I have my own hobbies. Don't judge my hobbies. I won't judge yours. I'm not going to smack the kid. I just want to tell him to do something better. But like, if you got a memory like that, do some cool stuff with it. No one cares how many digits of pi you know. Okay, so speaking of pi, this is worth it. Here, this is the Jet Propulsion Lab. Propulsion Lab. Digits of pi we need. Did we do this before? jpl.nasa.gov. How many decimals of pi do we really need? So to calculate pi, this is highest accurate calculations. They use pi to, how many digits is that? 16? So Voyager 1 is about 15 billion miles away or so. If you had a circle of that size, 30 billion miles in diameter, you want to calculate the circumference using pi to the 15th decimal. Let's see, where does it say here? You'd be wrong by less than half an inch at 15 billion mile radius. You'd be off by half an inch with 15 decimal points of pi. I think that's sufficient. I mean, at that point, I'm pretty sure there's weird gravity stuff. I don't understand how gravity works, I'll be honest. I didn't take physics. It's complicated though, right? So like when you shoot something out into space, like it's affected by everything. I have no idea how to calculate this stuff. Those people are amazing. E equals mc squared. Yes. Okay. Anyway, so you don't need that many digits of pi, especially not 100,000, or to memorize them because they're written down. How did we get there? I'm sorry. Anyway, we started writing pi. That's what it was. And you guys were impressed I knew so many digits. All right. So if we wanted to read these numbers and do something like, let's sum them. Let's pretend like this is my register here. And I'm like writing down all my transactions. So I know how many dollars are in the drawer at the end of the day. Right? That's something practical, right? We could do this sort of thing. So let's convert all of these. So I'll have a double for the total. Here, starts off at 0. Right? And then I'm going to read the line, and then I'll have a double for the value is double.parse double of the line. Again, you can do that all in one line if you want. You don't have to store it and then parse it. That's okay. I'm not even going to print it out. I'm just going to take total plus equals the value. Right? And then we're done. We can print out total value of numbers in file is, and we can append in here the total. Right? Let's give that a try. Is it 63.14159.265? Probably is. Let's see. 1, 6, 11, 16, 37, 39, 60, 63.14159.265. Look at that. It added up the numbers. Did you imagine Java can add numbers? I'm sure you're all impressed with Java. Yes, clap for Java. So this is more interesting, right? If we give it some sort of file and then do something with it here, right? So reading files and writing files, it's not too bad. Right? We read them with scanner, so we give it the file. Now, if this file doesn't exist, if I typo this, because I do that all the time, if I have test.txt, it's going to crash on me here. It says, uh-oh, this is a file not found exception. The system cannot find the file specified, test.txt. Doesn't exist, so it crashes because we told Java, hey, it's okay if you crash. Now, if you don't want to crash, which is probably a good thing here, there's things we can do to avoid this. So maybe we ask the user here. So let's ask them here. So let's make a scanner. We'll call it keyboard. Here is a new scanner. Given system in, system.in, and we'll say enter the name of a file to read, and then we'll get a string for the file name, keyboard.next line, and then instead of opening up test.txt, let's open up the file name. Right? I don't know what the user is going to tell me. Let them tell me something. Let's try it. So if I give it test.txt, it works because I gave it the right file name. If I give it test.txt, it crashes on me. Again, we probably don't want it to crash. So what could we do instead of crashing? Well, the file class turns out knows how to deal with this. So you can ask the file if it exists. So file to read dot exists will give you back a true or false. So we can say while the file to read does not exist. Right? Let's enter the name of file. Make file to read equals that file. Maybe tell them that file doesn't exist. Doesn't exist. Please try again. And maybe that's the whole prompt instead of enter the name of a file. Can we just do that? So if the file doesn't exist, we ask them again. So we're using a sort of a validation loop. Does the file exist here? So test.txt, file doesn't exist. Try again. Test.txt, now it works. Right? So we can still work with the user input and avoid crashing just by making sure the file exists before we open it. For writing, we don't care. Right? We'll happily overwrite a file or create a new file. Both work. But for reading a file, if it doesn't exist, you can't read it. I think that makes sense. Right? So the option is crash or ask them for the real file name if we're dealing with user input here. Right? Okay. Excuse me. So what if we wanted to store some stuff in files, right? Like a grade book, right? Like I could go through and ask a bunch of students, that sort of thing, and store their information in a file. Would that be useful? Let's do that. So should I leave this one here, make a new file or something? Or I don't know. All right, a new file. All right, let's do that. So instead of main here, let's just do a new project. That'll be fine. Here's week 10. This will be files with classes. So we're going to use a class here for this because right, classes are nice. We like classes. We like thinking about things in terms of classes here. So I'm going to write a class for student. Right? Attributes of student. You probably have a name. Right? So private string for name. String for name. And then probably what? Have a list of assignments and scores maybe? Let's do that. So we'll have a private array list of type assignment here called assignments. And no, assignment doesn't exist. Assignments, there we go. So let's write another class here, right? A class can have another class. So let's write a class for assignment. So assignment, oh my goodness, assignment, there we go. Yes, I named the file wrong. Rename assignment. Did I do it? Okay. Assignment. We'll have a private double for max score, private double for score, and a private string for name. Right? Or how about we do name first? I don't know if it matters, but so the name, the maximum score for the assignment, and the actual score for the assignment. Right? And then if a student has a list of these things, right, we can go get and set those values. So that's all assignment's going to do. So let's go add some gets and sets here. We'll generate getters and setters for all of them. And then I like constructors, right? You should always have a constructor because its job is to give default values. I like constructors that take arguments, right? So you should know what they are ahead of time. If you want to give it a default constructor, that's fine too. That's no worries here. That's okay. So right now it's upset. Let's see, an array list here. Let's see if we can fix that. We got to add our import. Okay, make an array list of assignments. Cool. So student, and then we have a list of assignments. We should be able to generate our score from that, or our grade from that, right? So for student, let's add a get and set. So you got to be a little careful with these here. If you give someone access to your array list here, they can go and change it. Right? So when I give you back my list of assignments, you can go and add to it, subtract from it, modify it, do anything you want to it, because you have my array list. Right? It's a reference. Here's the reference to this array list in memory. It might be better to give them a copy of this. You know, that's a choice you get to make. So I'm just going to add like a be careful, giving someone a reference to a list and modify it. And for setting, again, also risky, because once I accept your assignments here, I now am pointing my list of assignments at your list of assignments. We have two variables pointed to the same location in memory. If you go change yours later, mine's still looking at that same place. It's also going to have been changed because it still points at yours. So copies are probably better here, but again, sort of depends on how you want to do it here. So you can say assignments dot clone will give you a new version of it here. Is an option, or no, is it not clone? No, shoot. No, we don't want shallow copy. Oops. Copy. Hang on. Let's just Google it. Java deep copy array list. Let's see. It's not the answer to the question. Collections.copy. There we go. That sounds like that ought to do it. So we can return a new array list. I guess we got to do this in more than one line here. So we'll make an array list. This is my of type assignment. We'll call this one the copy. There's a new array list. And then collections.copy my assignments to the copy. And yeah, we got to import that, Alt Enter, then we can return the copy. All right, so we can do that, and we can do the same idea here. We can take the copy, so we'll say collections.copy. We want to copy from the assignments argument to my this.assignments variable. Oh, am I backwards? Oh, the destination and source. I am backwards here. Oops. Not the copy, destination, and then the source. So destination and source. All right. That's why those like helper pop-ups are nice. It didn't give me that. There it goes. Destination and source. Okay. So this is probably better. We've got a copy here, right? And we're not going to be changed later, right? Now, should be good to go. You could also have a add assignment here if we wanted. So public void add assignment, given an assignment. Take our assignments dot add assignments. There we go. Add the assignment. Right? We can do that if we wanted. Oh, that's a Boolean. We might as well return that Boolean then, because that tells you if it worked or not. All right, so we can add some assignments. You can't remove them, but that's fine. We could figure that out later if we wanted to, or we could just use the set here. So this is safer. Should be safer here. Then we have our assignments here. Right, set gets. That's all we need to do here. So now we can go get some information here. So first we want to do is ask them to give us the name of a student. Right? You do that sort of thing. So let's ask for the name of a student. So enter the name of a student. We'll have a string for student name equals keyboard.nextLine. Oops, we got to add that scanner here. Scanner keyboard, new scanner, given system.in. And yeah, let's add the import here. Oh, it did add it, of course. Nice. All right, so we'll get the student name. We can make a student. So student equals a new student, given the student name. We add a constructor for student? Oh, we didn't do that. Shoot. We need a constructor. So let's add a constructor for student. Now, I know if we make a student with a name, that should probably work. Maybe we can make assignments be a new array list. And maybe we add a constructor that takes the assignment as well. So we can add, you can have more than one constructor. So if you have more than one, you can do both. And again, we don't want to do this. We want to call set assignments given the assignments list, because that way we get a copy of it. Right? We already did all that work to make copies. Don't do it twice. Right? Just use your set method. Okay, so we'll make a student with a name with an empty list of assignments, and then we can go ask them for some assignments. So maybe we have a string for assignment name equals, we should probably ask them first, right? So enter the name of an assignment, keyboard.next line, and then we need to get the max points and the student score on that assignment, right? So ask them for, enter the max score for the assignment, or we can even give them like the assignment name in here, right? Which is kind of fun. Assignment name, and then we'll get a double. Was that a double or an int? I don't remember here. Yeah, double. Double for max score is going to be keyboard.next line, but that's a double, right? So we need to parse it. Oops, wrong key. Double.parse double. Given the keyboard.next line. Cool. And then the student's score for the assignment. So that's the max score. Enter score for the assignment name, right? The student's name for the score, and this will be the score. Then I can make a new assignment here. Assignment equal to new assignment, given the assignment name, the max score, and the score. Then I can take my student, I can call add assignment, given the assignment. It's a lot of work, right? But now we have one assignment. And then what if I want to do this over and over and over and over and over again? Right? We can put it in a loop. Right? Sure. So let's do a loop here then. So how about we say, let's move this up here. Let's say assignment name is equal to blank here, and while assignment name dot equals ignore case, I don't know, stop or something. Well, it does not equal stop. Let's keep on going. And at the end of this, then we need to ask them for a new assignment name. Right? So get the assignment name, great, or stop, or I guess stop is pretty clear here, right? Or stop probably works. And then if they entered stop, right, we want to not do this sort of thing. So we could put another check in here, which is a little bit ugly, or we could ask twice at the beginning. It's probably fine here. I don't know. I don't love either way. So if it does not equal stop, then we'll do all this stuff here, right? So if they entered stop, none of this runs, right? Otherwise it runs. We ask for the store, we ask for the student score, we add it. Great. When we're done then, right, I want to save all the student's information, right? So let's take the student's information and write it to a file. Now, is that the sort of thing students should be able to do? Maybe. Can we add a method for student? Like public void write to file? Can we do that in the student class? We probably could, right? So let's try it. So let's make a file. So file equals, oh, I'm sorry, we don't even need a file, right? We can just write the data. So we want a print writer. Print writer equals printer writer. No, print writer equals a new print writer, given a new file writer, given what's the name of our file? Well, we probably want the name of our, we can use our own name and then like add .txt to it here. And again, sure, it's upset. Let's go add some imports here. So import the class, and then we want to add the exception to the method signature. So if a method that is not main can throw an exception, you can add the same thing and say, hey, this method throws an exception. It's okay. Writer. There we go. So make the new print writer here. And then what do we want to do? Well, we want to write every assignment here to the file. Well, assignment could probably give us a string representation of itself if we want it here. It's just an option. So let's do a public string get string for file. How about that? We'll get a string for the file. Now, did we look at string formatting before, where you can use the .format method and use the substitutions? Does that ring any bells? Okay, that's what we can do the hard way then. So we're going to return, I want the assignment name, right, plus. Now, when you write something to a file, you can either put one per line, or you can put them all in one line and use some sort of special character to delimit them or separate them, right? Have you heard of comma-separated value files, CSV files? Commas are popular, but turns out some people have commas in weird places, especially like names. Commas are not as common in names, but weird stuff can happen. So commas are not generally safe for delimiting things like that, and you can get in all sorts of trouble. I'm quite fond of the pipe character. That's the shift backslash over the enter key. I've never seen anyone use a pipe for anything ever in like practical use. So it makes for a very good delimiter because you're probably not going to see it anywhere. Now, it turns out there's a particular format of file or a file information transfer in healthcare called HL7. Doesn't really matter, it's okay. But they use pipes to delimit their fields, and I think it's fun. So pipe delimited is an option here. So we'll do name, then we'll take the max score, and we'll add another pipe here, and then we'll add the score. So that is the string version of this assignment. So I'm going to write that. So I can say for assignment in assignments, assignments. Oh my goodness. We can take my print writer and we can print line the assignment dot get string for file. Get string for file. Right, and when we're done, we can close our print writer. Okay, so when I'm ready to write the student here, we can take my student dot write to file. Now it goes red here and it says, hey, unhandled exception, java.io.io exception. There might be an exception here. Again, we're just going to pass the buck. Let's just add the exception to the message signature. So if you call a method that throws an exception, it's also going to warn you here. These are known as checked exceptions. You have to deal with them or crash. So we're just going to tell Java, hey, we'll pass the buck. We'll crash. It's okay. All right, so we should be able to get a student here. Let's see if this one runs for us now. All right, so let's add Eric. Okay, enter the name of assignment here. So how about lab 1? The max score for lab 1, 10 points. How did Eric, students score for lab 1? Oops, I wanted student name. There we go, student name. There we go, right? Enter, I think that's it there. Student name, okay. All right, that's fine, we know it's me. We'll say I got 10 out of 10. Let's do one more, let's do lab 2. 10 out of 10, and then stop. Now there's an eric.txt file, right? That's the name of the student here. And it has lab 1, 10.0, 10.0. So we were able to write the data to a file. Now, how do we read the data from a file? Well, that's a little bit different. So what we could do then, right, I don't have a constructor that can take a string for file name. Right? When you have a method, when you have more than one method, the signature has to be different here. Something has to be different here. But how about I make a public student that takes a file here? We're going to go read the file. Can we do that? So I'll give the file here to the student constructor, and we'll go read the data out. Sure, why not? So we'll say name equals file dot get name. Right, that's the file for its name. That's the name. Now, I don't actually want the txt though, so I'm going to call replace dot txt with empty. So take the txt and replace it with nothing. So it'll get rid of the .txt here at the end of my file for my name here, because I don't want to be named eric.txt. I want to be named Eric. Okay. Then I want to start reading the file. Right. So let's create a scanner. So scanner, this is my file reader, equals a new scanner, given the file. I'm sorry, given, file here. And while my file reader dot has next, file reader has next, let's go and read it. So I can read the data out of the file here. Oops, we need to say we're going to just add the exception here. We might throw a file not found exception. That's fine. We can pass the buck. And we need to initialize the assignments here. So assignments equals a new array list, right? That way it exists so I can start adding to it. So as long as there's something for me to read, let's go read the data. So let's go get that piece of information out here. And it should have the name of the assignment. It should have the max score and my score. This will be my string for the line, is going to be my file reader dot next line. Then I need to split that up. We looked at split, right? String split. Did we do that one yet? We haven't done that one yet? Okay. So string dot split will take a line and split it into a bunch of different pieces. We should have done that when we talked about arrays. My mistake. So I can say here's a string array. I don't know, like parts here maybe is line dot split, and I want to split on that pipe character. So give me the pipe character and split yourself into different pieces to make an array of strings. Every time you find a pipe, split, make another piece of that string. So I should get the name, I should get the max score, and I should get the last score here. So let's split the line into string pieces every time it finds the character. Okay, that's our pipe character. That might not work here. Hang on. I think I need to, maybe it'll work. Split. Let's try it and see. I think that one works. Right, then the first piece here, so parts of 0, right, should be the assignment name. Parts of 1 should be the max score, and parts of 2 should be the current score, right, because it should split into 3 parts. I have indexes 0, 1, and 2. So you can make an assignment. Assignment equals a new assignment, given the parts of 0, right, for the name, double dot parts double, given parts of 1, and double dot parts double, given parts of 2, because those were double values, right? I want to turn them back into doubles. So it should split up that line into the 3 pieces. Every time I find the pipe, it should split, and then I should be able to get the values out here. Right, now I make the assignment, and then we'll add that assignment here. Assignments.add the assignment. So now I can construct a new instance of student given a file. Right? So let's see. So when I get the name of a student here, let's see if that file exists here. So here's my student name. So let's make a file for it. So file student file equals a new file given the student. Student name. Here we go. And we need file out here, import the class. Now we can check if the file exists, let's go read it. If it doesn't exist, let's go make a new one. So if my student file.exists here, let's make a student equals a new student given the file here. The new student given the student file. It should be able to go and read itself from the file. Otherwise, let's go make a new one here. And I'll go bump that down. All that goes into the new one here. Right? So we can say it's something like student file exists, reading file. And otherwise, we can say something like student creating new student file or something, creating new student file. Oops. Something like that, right? That makes sense? So if the file is there, let's go read it. Otherwise, let's go ask for everything here and get some new information. We'll try it. So I should be able to read the Eric file. Oops, I forgot to add the txt. Hang on. So Eric student name plus .txt. There we go. Try that one more time. All right, so here's Eric. Student file exists, reading the file. Uh-oh. Input string A, double dot parse double. A. There's no A here. Oh, there is an A in lab. Oh my goodness. Lab? Huh. I think the split was wrong. Hang on, let's see. Java string split. Let's go search that one up. Split. Oh, why? So it's splitting using this regex thing, which is really annoying. I think that's why. Regular expressions are annoying. Split. I want to just split on the pipe character. Hang on, let's try this. Student. Might have to give it in square braces here. Okay, this might work here. Let's try that. Eric. Okay, we read the file. Oh, we didn't do anything with it though. So let's put a breakpoint in. So after we're done here. So in main, let's put a breakpoint in here. Wait, oh, I gotta run in the debug mode. Oops, stop. Debug mode. There we go. Then we'll stop here at the debugger. So Eric. All right, we're about ready to step in. So let's step into, right? So I have the step over, I have the step into, or step into, no, just that one's fine. So here's the student constructor that takes a file. We're gonna make the assignments array list. We have the name here, right, for my file. We'll get the scanner. Let's go read something here. So the first line then is lab 1, 10.0, 10.0. Great, we're gonna split it into parts here. So parts is lab 1, 10.0, 10.0. Cool, that's split better. So with the square braces here, that's really annoying that we had to do that, but that's fine. We'll have the assignment. We'll see if there's more to read. There's more to read. This one is lab 2. Let's go read lab 2, add it to the assignments list. Great, we're done. There's no more to read. we're done here. We finished the constructor. All right. So then the next thing students should be able to do is be able to get the grade back out, right? So how about we add a public, what do we want, a double here for get grade? So let's take a total here. So double total score, the total possible points is 0, and a double for total points is 0. And for assignment in assignments, let's go take the total possible points plus the assignment dot get max score, and we'll take our total points plus equals the assignment dot get score here, and we're done. We're going to return then my total points divided by the total possible points, right? So we're done with all of this. We should be able to get the score back out of the student. So when we're done, student dot get, oops. So student doesn't exist outside of these curly braces, right? We declared it inside the curly braces. So if we want it to exist outside of that, we need to say, hey, I want a student here. And then inside, I just say, hey, Java, assign it a value. That way student exists outside the curly braces, right? It doesn't have a value, but either it will get the if or the else value. So then I can use it down here. So student.get score. Get score. No. Get grade. There we go. Get grade. Get grade. Thank you. And we should probably print that out here. So let's print out students grade plus the student get grade. Now this will be a percentage, right? Grade percentage maybe? Percentage. We'll have to do some arithmetic to turn that into a letter later. I think we did that like way back when we started talking about if statements, right? We said it was between 90 and or like greater than 94, this sort of thing. So if I have just Eric here, we should get a 1.0. I had 100%. So maybe we take that multiplied by 100. Why don't we do that? So let's multiply this by 100. That'll be a little bit prettier, right? So Eric, I have 100. Cool. So let's do another student. Let's add a new student file here. So let's do Jeb. Jeb's not been keeping up with his homework here. So he did lab 1. Say he got 7. Max was 10. He got 7. And then lab 2, he had 5. Oh, max was 5 and score was 5. Sure, why not? We'll say stop. So Jeb's percentage then is 80. Right? He had 7 plus 5, 12 points out of 15. 12 divided by 15, is that 80? 12 divided by 15, 80%. Math checks out. So we can use a class to read and write the data. And you don't need the class for any of this. You're welcome to write it yourself, but it gets a little tricky, right? You're going to have a lot of repeated code when we want to do different things. So having the class here lets the class worry about things like reading and writing the file, because it should know its format, right? It knows how to write it, so it can write its own file, and it knows how to read it if you tell it what file to read. Right? So main doesn't have to know anything about the format of the student class. It just needs to know, hey, I can give it assignments and I can get the grade back out. And if I want, I can load the student up or I can make a whole new student file. Right? That make sense? Cool. So we can do this sort of thing with files. Reading and writing files is awesome. Now, the other way of going about this, if you don't want to turn all these into this pipe delimited thing and deal with splitting. If you want, you can just write each individual assignment item to a line. Like, then you'll know the first line is the assignment name, the second line is the max score, the third line is your current score. The problem with that is it gets to be a little harder in your while loop, because you can't just say while it has next. You sort of can, but you can't read one line at a time. You have to read all of the lines. So I would say, okay, let me read line 1 is the name, then read line, next line would be the max score, and then line after that would be the current score. So I could read 3 lines at a time, and then come back and say, hey, is there next? And go read 3 more lines. Hey, is there more? Read 3 more lines. Hey, is there more? Read 3 more lines. Either way works. Now, it gets to be a little verbose at that point, and depending on what you're trying to save, it's an option. They don't have to all happen on one line. So that's just either way you want to go about it there. It's going to be okay. That make sense? All right, so we need to do a lab for file input and output, and we need to do a project for file input and output. And then we got to talk about the midterm. So we got 3 more things, and it's 8 o'clock now. Do you want to talk about one of those 3 things or take a break? All right, which one? All right, we'll go. All right, so let's go make a new lab assignment here. So let me go my classroom link. This will be lab 8. 3, lab 8. Java template. There'll be more. So once we get to the first GUI one, we'll have a lab, and we'll have a lab for correctness and robustness. We probably won't have a lab for chapter 13. At that point, like the only thing to do is the final project, really. But these other ones, we can do some basic labs. So this is like, can you get it working? A basic project. It's not very exciting. It's like a hello world with GUI. Just to make sure it works for you. This one is a lighter chapter. We're not going to spend the whole night working on this chapter 8 stuff, but this is when we get to exceptions and how we deal with them and that sort of stuff. It's important. And then we'll come back and do more GUI stuff to finish out the other things that you need for the final project. And then 418, just work time. I can go around, answer questions, and then you guys present and I shut up for once on 425. Okay? Awesome. All right, so here's our lab assignment here then, right? So let me go add a new lab 8. Wait, file IO. So we do next week. Labs. Turn in some text. Oops, where's my link? Oh, I didn't finish it. I got distracted. All right, so we're going to submit URL to repository. We'll write a program that allows the user to either start writing receipt totals to a file, name receipts.txt, or reads the receipt.txt file and turns the total and average receipt value. So the total value, like this is all the receipts, and then average, just because it's interesting. I should say total number of receipts and the average receipt value. We'll just calculate a couple things about it here as we're counting all the receipts here. So we don't need to know ahead of time. We just read them all out, count them as we go, add them to the total. When we're done, calculate the average. Right? It's total divided by number. What gives you the average? So I could start tracking all my receipts for the day, or I can run it and just give my data when I'm done, essentially. I don't actually know how cash registers work. I've been fortunate enough to never have to use one. I'm sorry? So it asks the user when it starts, hey, do you want to start tracking receipts or entering receipt values, or do you want to get your receipt data? Yeah, one or the other. Yep. But you'll do both in the program. Yep. So we did like the basic sum already with the other example. It's out there. Now, if you want to use classes, great. If you don't want to use classes, that's fine. We're not doing anything super interesting here that you would need classes for. When we do the project, you're going to need classes. So either's up to you. It might be overkill for this, but it might be good practice to write a class that can read the file, or write a class then you can go and add receipts, that sort of thing. Totally up to you. All right, so that's our lab here. And then our next project, project 3, this is our store, file IO. We got 2 weeks for this one, right? Puts us out to 6 p.m. on the 28th. Is that right? Should we do? We got the midterm won't be too bad. I promise. So if we're done on 3/28, we can start the final project, and life will be good. It won't be too bad here. All right. So we need another GitHub Classroom link here. Go back and make another one. 1500 project 3. All right. Please submit the URL to your repository. and a self-assessment using the rubric. All right, so this is a project. I'm going to turn in some text here. We'll add a rubric in a minute. All right, so we're going to have essentially two modes here. Similar idea. So we're going to have a manage shop mode and a purchase mode, or what, kiosk mode maybe? Kiosk mode. How about that? So to manage the shop, it is we're going to let the user go and add items for sale, update items for sale, or delete items for sale. Okay, so we can add items for sale, we can update items for sale, or we can delete items for sale. To delete, I forgot to show you delete. The Java, where is it here? It's in here somewhere, right? Java file. There's a delete option. You can delete a file. File.delete will delete the file, right? Pretty straightforward. Okay. Where to go? Back. This one. I have too many tabs open. My goodness. So manage shop mode lets us, add, update, or delete in a loop until the user is done. Okay. So if we're adding an item for sale, we need to ask for the item name, item quantity on hand, and the price. So, hey, I want to sell muffins. I have a dozen of them, and they cost $1.99 each. Great. Okay, so we will create a file. Create a file named item name.txt. So muffin.txt gets created. We're going to write the quantity on hand and price to the file. Okay, to update an item for sale, ask for the item name, and then display the current quantity on hand, and current price. So you have to go read the file out, right? Here's the item. Let me go update muffin. Okay, let me read muffin, tell you, currently have a dozen, currently they're $1.99, and then get new values. Ask for new values for quantity, and price, and update the file. That means write the file. Right? To update the file, you have to rewrite it, right? Okay, and then for delete an item, delete the file, or the item file. Right, this is file.delete. That's your hint here, right? So for adding an item for sale, if the item exists already, tell them to go, tell the user to use the update process or something like that. Update option, right? Update option. If the item doesn't exist, tell the user to go add the item. Right? So when you go add an item, if it does exist, tell them to go update it. When you go update an item, if it doesn't exist, tell them to go add it. Right? And delete, same idea here. If it doesn't delete, if the item file doesn't exist, tell the user. I don't know. You wanted to delete muffins? There is no muffins. You don't sell muffins. Sure. That makes sense? So that's the manage shop mode. So we're going to make a bunch of files here. So if I sell apples and bananas and cucumbers and donuts and eggplant and flour, keep on going. I'm running out of letters here. I can't think that fast. Right? We're going to have a bunch of files, one file per item. Right? It's one way of doing this. Loading up a single file with a bunch of items is doable, but this approach, one file per item, is pretty straightforward here. Probably easier than have an entire inventory, which is a list of files, kind of like we do with assignments. So I think this will be easier going this route here with the files. Okay, and we just keep doing this until the user's done in manage mode. Then for kiosk mode, I'm sorry, go ahead. Yeah, doesn't exist. Sorry, thank you. Doesn't exist. Tell the user, like, hey, there is no muffins to delete. You don't sell muffins, right? Okay. So in kiosk mode, then we're going to ask the user how much money they have to spend. And we're going to track their balance. Then we're going to ask the user to enter the name of an item to purchase. See if that item exists. So we're not even going to tell them what we have to sell. We're going to say, hey, what do you want to buy? And go look for a file with that name. If we have that file, great. Then we'll, if it does, tell them the price and how many are available to purchase. Right, that's the quantity on hand. If it doesn't exist, tell them they can't buy that. Okay. Right, so that's the if the item exists. If it doesn't exist, I guess we should do this one first, right? If it doesn't exist, if it does exist, then we'll ask them how many they want to buy. Right? Okay, how many of these do you want to buy? We're going to make sure the user has enough money. So if the user has enough money to buy that many, reduce the quantity on hand for the item. Right? That's update the file. Right? If I sell a dozen muffins, you come in and want to buy 3 muffins, and you have enough money to buy 3 muffins, right? It should cost you what, $5.97. If you've got at least that much money, great. I'll go update the quantity available to 7 or no, to 9. I can't do math. It's too late here. I need more coffee. Right? If they don't have enough money, tell them to try again or something. You don't have to do a whole lot here. Just you don't have enough money to buy that. They might not even have enough money to buy one. Right? If you want to sell big screen TVs and they walk in with $20, they're not walking out of the store with a big screen TV. Fine, right? Whatever we want to sell, it's fine. Okay, and then let's see. So track the balance and the purchase, and then we're going to keep allowing the user to purchase items until they are done, and then we're going to track all the items purchased. And at the end, print a receipt showing each item, the quantity bought, and total cost for the items, and a grand total for all items. Does that make sense? All right, so we have to track all the items. So not as they buy them. We don't say, okay, you bought 3 muffins. What else do you want to buy? Right? We'll just add that to their receipt. At the end, we'll print the receipt. You bought 3 muffins. You bought a dozen donuts. You bought, a bunch of flour. You bought some lard, and you bought some. What else do we mix to make a? What kind of bread? I forget what it is. That's fine. There's a really good recipe with flour, lard, and like one other thing. Is it biscuits? I think it's to make biscuits. Biscuit recipe with lard. Pennsylvania Dutch lard biscuit recipe. Here we go. Is this it? Flour, baking powder, salt, lard, and milk. There we go. Gonna make some biscuits. Make sure you have all the ingredients that you need. Only 3 tablespoons. Wow, for 2 cups of flour. I don't bake much. All right, so does that make sense? So there's shop mode, there's manage mode. Manage mode, we add, update, and delete files. Shop mode, we're updating files as we buy them and tracking the receipt. And they just keep on buying items until they're done. All right, so we save that, or let me add the rubric here. So this will be, I think we wanted, 25 points to keep on increasing our number of points here. This is project 3. This is missing, no points. This is complete. Let's do, I'm going to do 25. Can you do 5 each? So this is manage mode. No, that's not good. That's going to be too many. That's fine. Let's do 4 to start. So manage mode, add item, manage mode, update item, manage mode, delete item. And then we got a couple more here. So we got shop mode, check if item is for sale, and display price and quantity. This is shop mode. Ensure, ask for quantity to buy, and ensure user has enough money. And then shop mode, item file is updated after purchase with new quantity on hand. And shop mode, receipt for each item, quantity, and item total, and grand total. That puts it at 28. Is that okay? That's a lot more. Shoot. I do 3 each. How many is that? 21? That's not enough. Was there anything else? Did I have anything else in there? Manage mode, shop mode, receipts. 28's a lot. I don't want it to be 28. Can we do 3.5? I can do 3.5. There we go. 24 and a half. Is that close enough? Close enough. 24 and a half points. What? I could. You want it to be an even 25? All right, let's do custom points. Okay, so for custom points then, let's do add, update. Delete should be less because that's just a really easy delete call. 3, 3, 3, 3. What did that put us at? 22, 4, 4, 4. There's 25. How's that? So 3 points for shop mode. Check if it's for sale. Display price and quantity. Ask for the quantity buy. Ensure they have enough money. Oh, let's make that one 3. This one 4. Why not? There's 25 points. All right, that's the next project. We got 2 weeks on this one, and then the midterm, right? All right, give me a second here. I gotta go find last semester's midterm. This is, they already loaded summer classes, so I want fall. Here, let me put on the other screen real quick because I forget. Sometimes I click the wrong button and stuff shows up. Okay, why don't we take 10? And while I get the midterm ready to go, I'll get it loaded up. Does that sound good? Okay, so we'll take 10. I'll get that loaded up. We'll come back. Get me already. Do the midterm review.
Yeah.
Yeah, welcome back. All right, so I loaded the practice midterm here. This is last semester's midterm. We had it a little earlier in the semester due to some scheduling things. So that was fall. Yeah, I had the midterm when I was at Disney. That's why. That's what I planned for. No, nope. So it is untimed, open book, open note. So question number one, you get a point just for putting this in here. Yep. So enter your name to acknowledge you understand the academic integrity policy for the course as described in the syllabus. The midterm is open book, open notes, open internet, but you may not work with another person on it. All work submitted for this exam is my original work unless otherwise cited. You put your name down, you get a point. So there's actually been studies done. If you ask someone beforehand, they're less likely to cheat than if you ask them at the end to say, "Hey, I acknowledge that I didn't cheat at all." Like they did this study, and like people would be more likely to acknowledge that, but they did cheat. Versus if you start at the beginning, they're like in the mindset, "Okay, I'm not going to cheat," and they don't cheat, which is great. No, so you can't work with someone else.
Any other ways?
The internet's great. So that being said, the academic integrity policy still says stay off of Chegg and other sites. I had someone, before that was in the policy, take a midterm question, post it on Chegg, get an answer, because you can pay for people to answer your questions, and then cite their source. And like, hey, look, I found it online. Like, you're the one that posted it online, though. So, like, that's not cool, right? It's still... Yes. So you can't post the question and then cite that as an answer, right? Does that make sense? Okay. So a point for that. And then there are 14 quiz questions. They come out of the quiz test bank. So all the true false, like because they auto grade really easy. There's a couple, like I think one or two of these multiple choice, but those are harder to write and more obnoxious. Coming up with wrong answers is really annoying. So like I just don't do them usually. And then 3 long answer questions. So ours will be a little bit different here. So this first question was just on loops. We're going to do a question on classes. So like the last question here was a question on classes. Write a Java class midterm with attributes for student name, max score, and score. Write a constructor that accepts values for student name and max score. Default the score to 0. Add a get method for everything. Add a set score method that ensures the score is between 0 and max. If it's less than 0, set it to 0. If it's over the max, set it to max. So kind of like the lab assignment, but less work. Right? Smaller than the lab we did for classes. Yep. So write your code in IntelliJ and then copy paste. That's easy, right?
What if we just give up and choose not to answer?
You are welcome not to answer and get no points. It's up to you. So the 3 long answer questions are worth 5 points each. The other ones are 1 point each. So it's 30 points total. Half of them are the long answer points, half of the quiz points. So we'll have 1 on classes. We'll have 1 on arrays, and we might not do files though. Yeah, probably just a method then. So, you just come to student and copy and paste. Yep. Yeah. So you just copy paste it in. Yeah, I think so. We'll do 1 on classes, 1 on arrays, and then a third one just on a general method here because I'd like to do files, but we haven't really had a chance to practice them a lot yet, and we're starting that next week. So it is untimed, so it'll open next week at 6 p.m. It'll be due the week after at 6 p.m. So opens on 3/21 is due 6 p.m. at 3/28. Yeah, till 3/21. Yep. If you want to start it early, I can open it early. I've never had someone be excited to take a test. Yeah. So the idea is if you wanted to sit and take it in class next week, you could. It shouldn't take you more than, I planned for like 2 hours. So I said, hey, if each of these long answer questions was half an hour and then 2 minutes per quiz question, that's about 2 hours. We've got all 4 if we need them. I hate watching people take tests. It's terribly dull. And then like, usually people do worse when you watch them because like it feels stressful. So low stress, hopefully, like take it in your pajamas if you want, go for it. Take a little bit every week, go for it. Or every day throughout the week. However you want to go and take your test, go for it. So, open it, save it, come back to it, and we're good there. And then we'll meet back up on 3/28 then, and we'll cover Project 3 and the lab for files, and then we'll talk about Introduction to GUI Programming. We'll have a lab for Introduction to GUI Programming, and we'll talk about the final project. So for final project, I'd like you to work in pairs. I'm not going to require it. I think you'll get a better result if you do work in pairs, but it does add a little bit of frustration because you have to coordinate with someone else, you have to talk with someone else, you have to find, figure out who's updating what and work together. That adds extra work. So whether or not you're paired or not, you're doing the same project. There's not the extra work of coordinating with someone if you do it all by yourself. So it generally works out to be the same amount of effort, one way or the other, whether or not you're splitting it up with someone or not. As you've probably noticed, when you go and write a program, if you know what it's supposed to do ahead of time, it's much easier to write the program. So being able to talk out your idea with someone and say, okay, I think I'm going to write code and it's going to do this step and it's going to do this step and it's going to do this step and I'll have a class that has these attributes and I'll have these methods. You can find problems earlier and they're easier to fix rather than you find a problem after the code's written and it doesn't work the way you want it to and you have to go back and rewrite the code. So talking about your design idea, talking about the process with another person is going to give you a better result because you can do those steps in your head and be like, okay, is this going to work? And kind of mentally go through the model of what we've done to figure out how we want to solve our problem. So that in and of itself is fantastic. Even if you don't write the code with another person, at least talk through it with another person. I think you'll get a lot out of that at least. Yeah. The final project. Yep. You're welcome to partner with someone. I recommend it. I'm not going to require it, but at least talk with someone else about your ideas here. And I'll give you it. So I think I gave you this note before. I'm not good at design things. User experience, human-computer interaction stuff is not a specialty of mine. I don't ever claim to be good at it. I would love to at some point, but I've got a ton of things on the bucket list, so it's probably not going to happen. So I will give you a very ugly version, and that's perfectly fine. Ugly is okay because what we care about is function, not form, right? Go and take a class on human-computer interaction or user experience, user design later on in life, right? There's a whole class. You can get a whole master's degree in human-computer interaction if you want. It's really cool. People do awesome stuff with it, but we care about does it work. We don't care if it's ugly. So I will show you a really ugly version of what the final project could look like. It does not have to. I almost don't want to do that because then everyone does that exact same ugly thing and you guys can do better because you folks are much more creative than I am. But it gives you something to look at because not everyone has an idea of what it should look like in their head. So we're going to build a terrible game, but not a text-based game because we have buttons to click on, but it'll still have text because that's all we have. We don't do a whole lot with graphics because that's trickier to do. So we'll build a terrible game here for the final project. It should be a lot of fun. Fun if you like coding, and hopefully you do by now, right? It's been 10 weeks and you haven't dropped yet, so hopefully you're enjoying yourself and you know what you got into. So I think most of you folks, I think not all of you, were software engineering majors. I guess major is the wrong word there. The program, I forget what they call it, but that's fine. So there's a couple folks who take the class who aren't in the software engineering degree. They're not going to take other software classes, and that's fine. I'll miss you. But most of you, I think, are in this for software, and hopefully this is a good intro to programming, and then you can continue on to bigger and better things. Don't forget the summer semester. My goodness, this is winter. Is open for registration. Get on the wait list for object-oriented programming Java if you haven't yet. If you need the class. Because at some point soon they're going to kick people out if they didn't pay for the class because you can register and not pay up to a certain date, and then you have to pay by that date, and if you don't pay by that date, they kick you out of the class, which sucks if you get kicked out, but it's good for you if you're on the wait list. So again, pay attention to the dates. I don't know where they publish those dates, or you have to go to another page to go and pay for things after you register. It doesn't take you right to the payment page, which is also obnoxious. But again, this is not my website. A vendor wrote this, which I really wish they could have done better. For them being a software vendor, this makes me really sad, but it's what it is. Let's find this is Lucian company, LP, and its affiliates. I don't even know what that means. What is an affiliate? LP, is that a limited partnership? Interesting. They're not like an LLC? Sure, whatever. And they have a privacy policy. Oh, that's OCC's privacy. Anyway, don't forget about summer, and we can go from there. All right. Other questions, thoughts, concerns? We've got the lab to work on, due next week. The project is due in 2 weeks, and then next week the midterm opens. The midterm is due the week after. So in 2 weeks, you have the project due and the midterm due, right? But there's no new lab next week. Okay? All right, awesome. Thanks, folks. I'll end this so we can start working on stuff, and I'll see you in 2 weeks then.